Alright, so in finishing up this problem, again, if I stick in 5 here and here, I get 1 times negative 3 times positive 3, so I end up with a final answer of negative 9. The sum of the roots are 8 and 2, so if I add them together, I get an answer of 10. And the product of the roots, if I multiply 8 and 2, I get a final answer of 16. Okay. So why don't we go ahead and scroll down to problem C here. So again, you're going to be doing A, B, C, and also D. Why don't you go ahead and do problem C, and then turn the video back on, and then you can use whatever time you need to finish up B and D on your own. This will be the last problem. I mentioned A would be the last, but I figured since C and D have a leading coefficient of A, being 2, and problem D being 3, this one, again, you have to do an extra step in here, so let's make sure you understand what the extra step is. So go ahead and work on this problem. Turn the video back on. If you need some suggestions or hints, then turn the video back off and continue working on the problem. But again, we're trying to find all of these things and try to do as much of that as you can without my assistance in this video. Alright, so in both problem C and problem D, I notice all three of these numbers are even. So that means that I can factor out a 2, and in doing so, this number becomes a 1, this number becomes a 1, and this number becomes a 20. So what I end up with is 1x squared plus 1x minus 20. Now why that's important to be able to do is because now, since this leading number here is a 1, we can actually now do just a diamond. So I'm looking for two numbers that when I multiply them I get a negative 20, but when I add them I get a 1. And that's going to tell me that what the two numbers are going to be. Since I have a negative at the top and a positive at the bottom, it tells me that one of the numbers will have to be addition and one of the numbers has to be subtraction. So hopefully that's enough to get you started. If you've not already turned the video off, go ahead and turn off this time and finish the rest of this problem. Turn the video back on when you're ready to continue the discussion. So hopefully you came up with the numbers being positive 5 and negative 4. When I add them, I get positive 1. When I multiply them, I get negative 20. So it's x plus 5 and x minus 4. So for my roots, the first root is going to be negative 5, 0, because negative 5 makes this 0. And the second root will be 4, 0, because 4 minus 4, here, 4 minus 4 is 0. The y-intercept, if I let x be 0, basically my number is going to be 0, and this is going to be 5, and this is going to be negative 4. So it's going to be 2 times 5 times negative 4. But I let x be 0. So it's 2 times 5 times negative 4. So my y-intercept is negative 40. 2 times 5 is 10, 10 times negative 4 is negative 40. For my sum, I'm going to add the two together, so negative 5 plus 4 is negative 1. And if I multiply them, negative 5 times positive 4, my product is negative 20. For the vertex, we have to take our 2x numbers, our roots, and add them together, and then divide by 2, so negative 5 plus 4 divide by 2, so that's negative 1/2. Negative 1 as the numerator divided by 2, so that's negative 0.5. So that's my x value of my vertex, negative 0.5. And then if I go in here and replace a little space in here, replace x with negative 0.5, I get y is equal to 2 times 5 minus 0.5 is 4.5. And negative 5 minus 4 is negative 4.5. I'll focus on the decimal numbers first. So 4.5 times negative 4.5 is negative 20.25. And then I'm going to double that. So negative 40.5. And that is my y value of my vertex. Okay. So I hope that helps. Again, go ahead and complete B and D on your own, and then move on to the next handout. In the next handout, you're going to be starting with factor form and looking at turning that into vertex form, very similar to what we've done in this activity, and then eventually looking for a pattern between vertex form, and specifically the h value, and general form, when you have ax squared plus bx plus c is your relationship between the b value and the h value in the vertex form. We'll continue with our discussion on that on Thursday.